You're welcome to New Focused Approach to Mathematics Basic 8. This is revised edition, and in this lesson, we are looking at position and transformation, and the aspect we are looking at here is rotation. In Basic 7, we did that of reflection and translation, and now in Basic 8, we are looking at rotation. In Basic 9, we'll be looking at enlargement or dilation. This lesson can be found in page 239. Now, talk of rotation, what we are trying to do is how we can rotate an object or turn an object in a particular angle in a particular direction without changing the size or the shape of the object. So you can see this object has been rotated first 90 degrees and the second 180. The object still remains the same size. Nothing has changed. The shape is the same. The size is the same. It has only turned. And in this lesson, you're going to look at turning in terms of clockwise direction or anti-clockwise direction. Now, if you look at this object here, the symbol F here has been rotated clockwise direction. And we can do that also in anti-clockwise direction as well. When you look at this object, the triangle ABC has been rotated 90 degrees anti-clockwise. 90 degrees anti-clockwise. So how do we do this rotation, and how do we have an object and we rotate so that we can get the image? Now let's look at this example. This object here, we want to rotate it 90 degrees anti-clockwise, which is the same as 270 clockwise. And ideally, that is what happens. When you rotate an object 90 degrees clockwise, it's the same as doing it 270 anti-clockwise. That's what it means. So the direction of 90 clockwise is the same as 270 anti-clockwise. So what we do is that if you want to use, we have a formula approach and then we have protractor approach. Now let's do the two. For the protractor, what you do is that you first of all draw a line from the point that you want to rotate. Here we have 3 points here, A, B, and C. Draw a straight line to the center because you are going to do 90 degrees about the origin, so about the center or the origin. So after drawing the line from the point to the center, then you use your protractor to measure the angle 90 degrees, then you draw a straight line. With the help of your compass or divider, you can transfer the measurement of O to A and transfer the same thing to that of the line, and then to give you a new point. That is the image, negative 1, 1. The same thing can be done with the B, and we can go that way and we transfer the size, the length, and we get the image. Then for C, we do 90 degrees, then we transfer, then we get the image, and then we are able to draw the point. So we join the point to form a triangle, which is 90 degrees rotation anti-clockwise. So that is how we do it. But then we can do the same thing using the formula. In the formula, this is how we generate it. You see, let's have the point here. This is our y and this is our x. This is our negative y and negative x, right? So if the original point, say, is xy, and we are rotating it, let's say 90 degrees anti-clockwise, like we've done right now, you see that anti-clockwise, and we make reference to the positive y and positive x. So because you are going anti-clockwise, x will move to y direction, y will move to the x direction. So the position of the x and y will interchange as yx. Then with the x moving to the y direction or y position, x was positive and it went to the y also positive. But y rather went to the x negative. So we give y negative, which means that if your original point is 4, 1, your image will be negative 1, 4. And that is how we are able to plot all these point as well. So for 90 degrees anti-clockwise, this is the formula you're going to use. Then if you want to do the same thing for 90 degrees, or let's say 180 degrees, let's say we have xy, and we are doing 180 degrees, which is anti-clockwise. Let's go by the same anti-clockwise, and fortunately for us, both anti-clockwise and clockwise for 180 degrees remain the same. We get the same answer. So in this very case, If we are doing 180, that means S will move from its position and come to the same S position, but this time from being positive to negative. So S will still remain here. And Y also will move from Y position or up to the same Y position to be 180. So Y still remain here. But then S went to the negative, Y also went to the negative. So we give each of them negative, negative. So for 180, both clockwise and anti-clockwise, the formula remains the same. Then let's see 90 degrees clockwise. 90 degrees clockwise. So for 90 degrees clockwise, assuming we have XY, okay, and we are doing 90 clockwise, which is the same as 270 anti-clockwise. So you see the movement of this one. Here, the X point here, the S here moves 90 degrees to the Y position, and then Y also move 90 degrees to the S position. So then they'll be we interchange the position of Y and X. Okay, then with Y going to S position, it was positive, but then S going to Y position became negative. So we negate this one. So it means that when we have a point, let's say 3 or 2, 3, and we rotate it 90 degrees clockwise, the position will interchange. So 3 will go up and 2 will come down, but then 2 will become negative. And that's how we do this rotation using the formula or using the diagram. Okay, now look at this question. It says a triangle ABC has been rotated about the origin O to form the image A1, B1, and C1, such that A maps to A1, B maps to B1, C maps to C1. Determine the angle of transformation or angle of rotation. Okay, so what you do is that every time you are given two diagrams and then they've already done the transformation for you, they want to know what kind of transformation that has taken place. So since they are talking about rotation, and all we needed to know the angle of rotation, we will draw a straight line from the original point to the center, what they said about the origin O. Then we join from the point A to the image A. Then we can use our protractor to measure the angle here, and obviously the angle is going to be 90 degrees. The same thing can be done with the B. I can join the B to this and join it to its original image position, so that the angle between the two lines is 90. The same thing if you pull C also here and join it to its C position, you still get that 90 degrees as well. So this is the fair idea as to how to get formulas to generate rotation 90, 270, and then 180. Thanks so much for watching.